there's some technical issues at Mr. Arvind's end, so he's rejoining. So we'll start the session right now. Yeah, it's fine, sir, Mr. Arvind. Yeah, right. Hello, everyone. I'm Subjit Roy, welcoming you to 33rd episode of Mojo for Industry Development Debate on top Industry 4.0 trends and innovations in 2022. Program sponsor is IFM Electronic India Private Limited. Established on 29th of October 1969, almost 53 years back, IFM develops, produces, and sells sensors, controllers, software, and systems for industrial automation. IFM is headquartered in Germany and today having presence in all major countries across North America, South America, Asia, Europe, and Africa. IFM Electronic India Private Limited, that's the Indian subsidiary of IFM, is located in Kolhapur, Maharashtra. So coming to the topic of the today, digital transformation are bringing revolution across all aspects of our lives. Industry 4.0 is the digital transformation of traditional manufacturing or production activities. Today, Industry 4.0 offers endless opportunities for manufacturing companies. However, despite having tremendous opportunities in the past few years, only a select group of companies have started their efforts to implement Industry 4.0 across their manufacturing networks, and a large majority is struggling to capture the full potential of their transformation efforts or deliver a satisfactory return on investment, in general what we call as ROI. Today, in this Mojo for Industry Development debate on top Industry 4.0 trends and innovations in 2022, sponsored by IFM Electronic India Private Limited, we will discuss and deliberate on why should manufacturers adopt Industry 4.0 technologies and what do you need to get started with Industry 4.0. Ladies and gentlemen, before we get started, let me introduce you with our panelists for the day. We are pleased to join by Mr. Arvind Talange, Branch Manager, IFM Electronic India Private Limited. Welcome, Mr. Arvind.
Hello, welcome.
Then we are joined by Mr. Swapnil Kulkarni, who is the Managing Director of Smarcell Global Competence Center. Welcome, Mr. Swapnil.
Thank you, Subhajit, and hello all.
Then we have Mr. Sachit Mohan. He is the Senior Software Developer at Smarcell Global Competence Center. Hi, Sachit. Welcome.
Hello, everyone.
And then we have Mr. Rishi Ritik. He is the Field Application Engineer at Redline India.
Hello, everyone.
Hi, Rishi. So today, once the individual presentations are over, we will have a panel discussion followed by a brief Q&A session. So viewers, if you have any questions during this session for our panelists, please submit it in the Q&A box. Don't put it in the chat box. So in your Zoom control panel, we will address them at the end of the session. Now to take the session forward, I will invite Mr. Arvind Talange.
Yeah, thank you. I'll share my screen.
So Mr. Arvind is an industry veteran and has over 25 years of experience in the field of management of sales and marketing in automation industry. He is with IFM Electronics since 2002 for business development. His domain expertise includes automotive, robotics and handling, and food processing. Mr. Arvind is currently responsible of all India business development of IFM Electronic Solutions in automotive industry. Major solutions include Industry 4.0, condition-based maintenance, vision to enable overall equipment effectiveness that we call as OEE, improvement of the plant. Mr. Arvind will talk about why should businesses or the manufacturers rather adopt Industry 4.0 technologies. Over to Mr. Arvind.
Well, good afternoon, ladies and gentlemen, and welcome to an exciting webinar on the subject of why should manufacturers adopt Industry 4.0 technologies. We will also quickly go through some of the major trends in the manufacturing Industry 4.0. So the question, what prevents the technology from being adopted quickly? This is not a new concept. Many new technologies have come and gone from the industrial space, claiming to be the latest and the greatest. The main barriers usually revolve around these three major C's: cost, change, and complexity. This is the main reason why new tech isn't adopted quickly or at all. But what if we could eliminate these barriers? What would you do? This gives the understanding of how industry revolutions took place and with respect to technologies and the importance of Industry 4.0. As an industrial company, whether you are solving a specific problem or working through a large digital transformation project, collecting and analyzing data is critical part of the solution. The industrial Internet of Things, that is IoT, enables intelligent decision making by leveraging data to optimize operations, increase performance and availability of equipment, improve product quality and shorten time to market. So an IoT would accelerate and simplify the process of creating connected products and services for industrial environment. With this IoT expert application of technology to collect machine generated data, networking of all kinds and advanced big data analytics. So what is Industry 4.0? The most recent evolution in manufacturing called Industry 4.0 is actually enhancing computer assisted manufacturing through machine learning and smart technology. The latest industry evolution brought the manufacturing process into an age where computers and automated machines enabled factories to produce products on massive scale. This newest leap in manufacturing will further remove the human element from the equation. Although there are instances where human component is still essential, many of the latest Industry 4.0 trend makes it easier to create products without people getting involved. For example, machines are becoming more efficient in detecting, maintaining their conditions. So hiring as many people to run routine tests on devices is no longer necessary. So the connectivity network between machines and the rest of the manufacturing line is the main contributing factor to this technological revolution. And that is the data. So in order to remain competitive, companies, regardless of their size, will have to invest in digital technology. It's just not enough to see opportunities. We also have to size them. According to some experts, the most important prerequisites for this trend is intelligent products and innovations, as well as the new business models, which only become possible through digitalization. On one hand, they have to develop an agile way. On the other hand, they have to support their employees and focus on the requirements of the network customer. So digitalization specialists think that particularly small and medium-sized companies will have to become active. Despite reservation and initial difficulties, the companies have to come to the same conclusion, as becomes visible in a recent survey. In spite of the impression that digitalization may be a threat, most or 80% or more than 80% of the asked stated that Industry 4.0 is more a chance than a risk. Nevertheless, being aware of the potential offered by the digitalization is not enough. It is not enough to see opportunities. You also have to size them. The information gained helps companies of all industries to improve their value chains and optimize their process. This is where the role of data actually comes into the picture. For industry, this means new business models may emerge from evaluated machines, the use of sensors, real-time processing of vast data volumes. The information gained helps companies of all industries to improve their things and optimize their process. To make this simple, for example, industrial customers can generate data from the sensors developed and gain important information. And this information then helps to detect machine damage at an early stage and avoid consequential damage. This proves that digital technology do not only change the job profiles, but also generate new numerous jobs. And this is sizing the opportunity. I mean, even if the fear is that machines might replace humans as probably as old mechanization itself, expect the unexpected. After all, the third industrial revolution and the resulting increased automation prove that change can generate new chances. The prerequisites for new chances that companies in the interest of their employees recognize their potential and exploit it, developing intelligent products and services tailored to the requirements of the market by means of data. This is exactly what we have actually tried to accomplish. Some of the fundamentals of digital transformation is digitalization by virtualization of all the devices through an Internet of Everything, convergence of organizational and physical resources, where our goals are amplification and avoidance of waste and inefficiencies. There are numerous opportunities, in fact. The fruits of digitalization and how digital technologies creates new jobs. Digitalization changes in all areas of our life, such leisure time, consumption patterns, and working environment also. On one hand, there are many more IT expert jobs are vacant in Europe. On the other hand, about 1 million of people have to learn and to revise their way of thinking. No doubt the working environment is in flux. Both chances and risks are to be addressed. A typical digital value chain would be, say, for example, like this, say, from R&D to sales and supply chain and to manufacturing and after market service. The whole of the chain, which includes right from smart products, energy management, or say track and trace applications. So entire digital value chain, which will give you a transparency, flexibility, individualization, and integration are the key principles here. One of the very first and prominent state-of-the-art technology is advancement of an IO-Link. That's a communication towards sensors and actuators. This, if you can see, there are field devices where these field devices are actually connected to controllers. And now with the help of IO-Link, which is a new way of connecting field device, which will give you not only the data, but also to control the process and the machines. This IO-Link, which is one of the major trend what we see here in Industry 4.0, is the first step for IoT. Process transference from the sensors to ERP. There are different major values from one sensor. Another advantage is tamper-free. There is unique identification of each and every element of the sensors. These sensors can be replaced very easily. There are very, almost most of the control manufacturers are involved in getting into this IO-Link development. And this is, as already informed, less expensive than analog value. You can see here the consortium of IO-Link. There are almost most of the control manufacturers and related companies who are into this IO-Link manufacturing. So if you can see the IO-Link, which has been developed by this field device manufacturer, on one hand, at the bottom of the pyramid, you can see many more field devices which are connected to IO-Link master here. There are two ports which the Y path of this IO-Link master will enable one to connect this to a PLC for controlling the machine or the process. And at the same time, it also goes to a digital platform like Monio or IoT, you can say. In short, if you can see in conventional systems, values of analog sensors undergo several analog to digital conversion until they finally reach to your PLC. This is where we are trying to find out the difference between how analog is being connected to IO-Link. For example, a pressure sensor of having a 5.5 bar pressure, when it is connected to analog value here in PLC, it actually gets converted from analog to digital and digital to analog. And in the output, where actually your 5.5 bar input pressure comes to 5.3 bar. So there is a loss of almost a 0.2 bar, which is because of the analog transmission of the field device to the controller. While in case of IO-Link, this analog data is transmitted digitally. So there is always a high precise value precision is coming into the, because this 5.5 bar pressure, which is converted to the PLC, is exactly 5.5 bar. This is where the advantage of IO-Link comes while connecting any field devices to the manufacturing. Some of the trends in the IO-Link is that, say, profiles. So in case of profiles, via profiles, the function block, the PLC can access the process values of IO-Link device from different manufacturers online at any time. I mean, since the data is provided in a standardized way, thanks to the communication specification and the profiles parameters stored in the sensors, these different sensors will have an IODD file, which has got a bit information of what the output, the information, the diagnostic data, all this is there inside the IODD file. Another trend is that IO-Link safety, because over the years we have seen that IO-Link has become established for a sensor actuation communication system. And to benefit from this IO-Link in the field of safety technology, IO-Link safety is also developed, offering advantages such as reduced wiring, less conventional input and output cards needed, and use of analog measure values for condition monitoring. A typical IO-Link safety is like this, an IO-Link ProfiSafe card, which has got input from safety products like safety barriers, safety proximity switches, and all these things, which is connected to a ProfiSafe card, and this becomes one of the port of an IO-Link master to which all other field devices are connected. So in another IO-Link trend is an open industry. This actually enables seamless integration of IO-Link data via various gateways like say Profarious, Ethernet, EtherCAT, which actually exchange the formats between IO-Link to higher level products. And there is one more trend is the wireless. In the field of automation, mobile communication standards such as IO-Link, 5G, or even Wi-Fi 6, these are becoming now building blocks for real-time machine-to-machine communication. So IO-Link is also coming into this place. There are many more IO-Link advantages, but here 4 basic steps in enterprise digitalization is collecting the information, say from maybe from PLC directly from the sensors, building and distributing the information. This could be by means of an IO-Link, Ethernet, and optionally maybe edge connect devices in hybrid systems with or without cloud connectivity. Machines which act actually automatically or autonomously. On one hand, via real-time network. Maybe example, machine is switched off, or on the other hand, by linking and analyzing information on computers and servers. And the last is predictive analytics. The big data and machine learning and AI tools help to improve future business processes and decision by making easy machine behavior learning also. A typical example here with the Industry 4.0 is with the help of IO-Link. Here you can see 2 motors with vibration sensors mounting on it, which are connected to an IO-Link master. This IO-Link master is giving you a data of a root cause, a report. They can report also. It can give you raw data also. For example, in case of vibration, it gives you a data of VRMS, ARMS, A peak, crest factor, and temperature. So all these alarming points are being taken care. The analysis is also taken by root cause, the reporting, and raw data also. It also gives you notification, email, and text messages via, and it also gives you a plotting of history or reports with this visualization and IO-Link block. Another trend is, say, for example, an artificial intelligence. Artificial intelligence has performed routine tasks for some time now, but with machine learning, the technology is poised to increase its scope. Traditionally, artificial intelligence operates from a set of rules and that provide guidelines for actions. Today, AI goes back to review the decision made by human beings and uses it to help to create new rules or refinements to existing rules. This increases the number of use cases where AI can operate independently. Here, for example, in case a smart limit watch of IFM Electronic is the tool of Monia Data Science Toolbox, which offers solutions based on artificial intelligence. User benefit from the permanent monitoring of critical process value with regard to the production quality or the plant condition, maybe a temperature, flow, or vibration or current. We are actually trying to differentiate a static process monitoring is a normal condition and an automatic way of a dynamic process monitoring. Maybe one example is a smart pump monitoring, extensive condition monitoring of a supply pump. The supply pump, which is actually a critical, one of the critical component of a CFA plant. It ensures media circulation through the entire system. If the supply pump fails, the entire plant process will come to a halt. Now, as the pump is operated at various speeds, depending on the cleaning steps, static monitoring is very difficult. The aim is to implement artificial intelligence based on the pump monitoring in order to detect and report any deviation of the operating state in the time. So maintenance first can be carried out here. Here, the many parameters of pump like current flow rate, pump outlet, current pressure, vibration data, operating hours, and pump monitor. All these parameters is being taken care by an artificial intelligence. Another trend is an augmented reality. Actually, augmented reality replaces in a common man a paper with a screen positioned in the worker's view. The screen superimposed work instruction on the physical material, so the operator can see the right way how the work should be done. This helps ensure that works use the latest processes and revisions and can also reinforce training. And as a result, productivity and efficiency improvement and costs go down. One of the new AR headsets of Magic Leap 2 featuring the PMD, that is Photonic Mixed Diode 3D technology, which has been developed by an IFM Electronic, which actually finds out the depth. Some of the examples of automotive market is that this technology is used to operate an infotainment system, gesture control to monitor occupants in order to trigger airbags integrally. In the XU area, the 3D technology covers environmental monitoring in the near field around the car. In another sector, say for example, 3D depth detection helps robot to find their way around the factory or for the quality management in the production line. The technology can quickly, reliably detect inaccuracy in production in millimeter range and send this information to an ERP system. One more is the cloud computing and edge computing. Cloud computing means outsourcing services and their user-related invoicing. The user does not need to care about the installation of software and hardware and operation. The execution of the programs that are not installed on the local workstation, but remotely in the cloud. There are different kind of clouds, applied cloud or application cloud. Our edge computing, in contrast to cloud computing, refers to a decentralized data process at the edge. Edge computing is the process of processing data at network periphery. That is where the data is generated rather than in a central location. The advantage of edge computing is cost reduction, faster data transfer, and additional level of security. Here we can see some analogy of how car driving and edge computing is there. There are different types of cloud computing, a private cloud, a public cloud, and say hybrid cloud. Depending upon our requirement, we can choose different clouds. So this kind of Industry 4.0 trends helps you in getting a navigation or virtualization, recording, and analysis of the data. So how visualization and evaluation of the process value, that is data acquisition and diagnostic. Detect and avoid adverse operating condition time. Process monitoring, that is analysis and trend creation. Ultimately avoid consequential damage by timely intervention. And finally, it reduces repair and maintenance cost. Thank you. If you have any questions, please ask.
Yeah. Thank you so much, sir. And we'll take the questions at the end of the session.
Thank you.
Right, sir. So thank you so much, Mr. Arvind, for explaining the benefits of adopting Industry 4.0. Delegates, if you have any question for Mr. Arvind, please submit it in the Q&A box in your Zoom control panel. We have already started getting the questions for him. So we'd request him not to answer those questions offline, like we'll take those at the end of the session. So ladies and gentlemen, our next speaker is Mr. Rishi Ritwik. Rishi has over 12 years of experience in the field of IT and OT convergence. He started his career with Siemens OT Solution in 2010 and automated industrial processes with PLC, HMI, and SCADA system. Later worked as product manager in Renew Electronics and assisted engineering with field problems and incorporated new technologies and protocols in the device. Presently, he is working in Redline Controls and executed many projects to provide Industry 4.0 solutions to overcome customer problems with IT/OT integration. Now, Rishi will talk about what you need to get started with Industry 4.0. Over to Rishi.
Thank you. Thank you, Subhajit.
Right.
And thank you for giving the platform. So in my presentation, I will cover what we really need to achieve the target to achieve the Industry 4.0. So before going to the topic, I will just explain the revolution, which is well explained by the panelist. I will just give, if we see the trend from industrial revolution, it is from mass manufacturing to customized manufacturing. So we have adopted this development trend for mass manufacturing from animals to machines, and now we are in the transition of making it a customized manufacturing. So Industry 4.0 is basically IT, information technology, and operational technology convergence, and to provide customized and customer-centric solutions to the industry. And so it comprises of Internet of Things, where we have discussed that we have a smart sensor. We need a smart sensor which will with easy connectivity, the smart connectivity solutions to provide data for analysis, and the cloud computing, where we need a server to be hosted on the internet, because of the in this era of the development of the internet and the connectivity is more. So we are able to implement this. So we need a server to be hosted on the cloud or to hosted on the internet, where we all the sensors from different location of the globe can put the data into a centralized location for data processing. After the data is achieved, we need AI/ML software solutions where these data will be processed for data analytics and for a reliable and data story where the user can easily understand what's going on in the field and what's going on in the factory. And then edge computing is needed for local controls, because if we put all the control solution on the cloud computers, then the emergency and fail-safe systems will not be required. So edge computing enables the processes, they enable the machines to take decisions and to act according to the requirements. So there are some predefined requirements in which the edge computing can easily help to achieve the targets. Once we collected all this data, so data is now new power in industry 4.0. So we need the security, we always need security to store our save our power, and for that cyber security is very important integral part of industry 4.0, where we need data protection, encryption and decryption topologies which cannot be hacked, and security over the transmission of the lines and security over the data transmissions. And the big data is the last one, which is where we have a lot of machines and lot of data to be flowing on the server. So we need to have topologies to control these data flow and to manipulate this data. So we need a big data analysis and big data analysis algorithms and softwares to be enabled to do this. So talking about the company Redline, so Redline has from 1972 is serving in the field of industrial automations and trusted by thousands of companies. And we are into the we are a part of Spectris PLC. So it is a London Exchange listed company, UK based company, which is taking care of the Redline. And we manufacture the components which enable, which helps user to achieve and to overcome the two difficulties which we have discussed. The overcome the complexity of the problem to do the change, and to make the change easy for the consumer or customers to switch their devices to industry 4.0. So during the product portfolio, we have all the product portfolios in the basket which help the users to integrate, to escalate their and to protect their data and to analyze and help the OT-IT convergence. So IT-OT convergence, which is a basic thing. So here the main challenge is access of IT to OT data, because in industry 4.0, the trend what we are seeing is the information technology and operational technology are joining hands to make the data more reliable and profitable. And also for the customized production and customize, there is a link that business processes should link with the operational technology and operational processes, so that the data, the production should be seamless, and the losses and other breakdowns should be minimum to achieve the target. So for this, the toughest thing is, the challenge is we have a two misalignment goal integrations. The IT has security, availability, reliability, and data scalability, and OT has production uptimes, throughout, efficiency, quality, and safety. So the goal alignment is different, but we need integration to achieve our target of customized production and industry 4.0. So to overcome this, we have seen the production architecture is also changing. So you have seen from input output signal to PLC, SCADA, MES, ERP system, all this getting into the fabrication and manufacturing processes. So data acquisition and data planning are both two-way sources in an operational industry, which is taking place nowadays very effectively. So Redline devices, which you see Crimson, helps in achieving these two processes to combine and help user to easily connect and easily get all the data and IT/OT infrastructure to be at the same level and the same place with easy integration of the Crimson software. So the Crimson software is basically rugged and advanced, and it is very easy to use, and there is no expertise of IT is required and OT is required. Existing infrastructure, in existing manpower, we can integrate and we can use these devices to scale our existing asset to a industry 4.0 platform. Because if we going to change for the new development, it is very easy to put the smart sensors and other things. For retrofitting, it is very useful to use a device which is intelligent enough to do your retrofitting jobs, to put your existing setup to the new environment and new technology. So if we have all the red line USB is, it can handle simultaneously up to 10 protocols and have a library of 300 plus protocols inbuilt. So the customer only need to connect the devices, the asset, their OT devices to these devices and directly. And since it has a inbuilt library of the protocols and edge computing, so they can use that library easily to integrate with this multiple vendor level devices, and they can integrate into the Redline devices. And these devices, after retraining the data, can be used for data control, monitoring, and aggregating and analyzing. So it helps in fulfilling the integral part of Industry 4.0, the data visualization, the data analysis, and the edge computing. And it also helps to push all these data to the IT infrastructure. It can push data to the SQL server, SQL server. It can push data to the cloud, MQTT, and it supports all the clouds and all the SCADA and all the traffics which are well known in the industry, like AWS, Azure, or generic MQTT also, in which we can use Node-RED or Mosquito, like these servers locally hosted. And it has the transmission is totally secured, and the device is modular. So you can put the device today and you can switch it, because these are modular. So these are 5G ready. So the technology is changing too fast. So it is very much needed for the industry to adopt the technology when they are adapting the new technology, that can be modular, because what pace of change we have seen in the technology in the past decade is very fast now in the current decade. So the technology will definitely change too fast now. So our hardware should be capable of adapting that technology easily, so that we can use this for the infrastructure. So the main benefit, one of the most benefit is also of this hardware, is they are very compact in design, very pluggable and modular, and they are very easy to use. So you can see here, we can easily gather input in a PLC, and since we have a library, so we can integrate sensors also directly, and we can integrate PLC also directly to the devices. And these devices can do certain level of packages, IoT packages, where you can visualize the data, you can analyze the data, you can do edge computing through this PLC to the field devices, and you can send this data to the IT infrastructure. And these all devices supports all the network, Wi-Fi, 4G, 5G, or GPS, and analog IOs, sense PID IOs, all the IOs are supported. So the software Crimson 3.2 is very easy to use, and can be easily is come with a package of hardware. So there is no licensing which we see in a software in the trend. There is no licensing, there is no annual maintenance. So you can use this software for configuring the device, and the device can be used as a runtime. And there are modular type controllers and modular type software. So hardware is also modular, you can, and the software is also modular. So it gives a versatile facility to the customers to choose according to their need and escalate it to the next level in the existing setup. Some of the claims of applications which can be developed with these hardware. So these hardware can be analyze the line downtime, and can escalate it to different level with different scenarios. So whether it is a mechanical breakdown or it is electrical breakdown, and maintenance can be implemented immediately. So we can minimize the OT level infrastructure by reducing the breakdown. Then we can have a design of our processes in a local and-on system. So a smart and-on can be also integrated with these devices, where we will have a clear idea of what's going on the processes, what's going on the plant. And we can have a Tuffler, where we can see the performance of different lines and different processes at a single place, at a single line. We can also do some edge computings. We can do some calculations of KPIs, OEE, availability rate, and all these things in this hardware inbuilt. And not only this hardware can be also used to connect to the TV, smart TV, where you can publish into the larger screen and view all these data. And one more thing, these hardwares are very effectively used for catering these all data to the IT infrastructure also. So IT doesn't have to dig a must of their minds in capturing these data. So these devices helps in overcoming the challenges of IT OT integration very easily with their 300 plus protocols and other features. So this is a running line. You can see assembly line monitoring, where the operator will get immediate action of material breakdown or system fault or quality issues. Any issue can be immediately intimated, and runtime can be seen and performance can be live on a real-time basis, so that the operator performance, the manpower efficiency will get increased because with the real-time monitoring of their performance. And also we have in the field of inverter monitoring, weather monitoring, and solar monitoring systems, where remotely the data is getting captured and thrown onto the cloud servers, and automated billings and automated generation reports can be created through the IT infrastructures. So this is all from my side. Thank you.
Thank you, Rishi, for sharing details about what is Industry 4.0 and what is needed to get started with Industry 4.0. At the same time, you have actually presented some of the innovative technologies that are being presented by Redline Controls. So delegates, if you have any questions for Mr. Rishi, please submit it in the Q&A box in your Zoom control panel. Industry 4.0 offers a new vision for the factories of the future. And these factories of the future, safety will be very much critical. Now, in this 33rd episode of Mojo for Industry Development Debate on top Industry 4.0 trends and innovations in 2022, sponsored by IFM Electronic India Private Limited, Mr. Swapnil Kulkarni and Mr. Sachit Mohan will talk about the important aspects of safety in the era of Industry 4.0. To give a brief introduction, Mr. Swapnil has over 18 years of IT experience, predominantly in manufacturing industries. He started his career with Skoda Auto India as trainee and grew up to senior manager. Then in 2014, he took the charge as IT manager at Smarshall India, and this year he got promoted and appointed as the managing director of newly formed enterprise by Smarshall Group, named as SGCC, that is Smarshall Global Competence Center, located in Pune, which supports all IT and engineering services for the group. And with him, we have Sachit, who has more than 10 years of industry experience, having worked with initial years of his career with multiple startups, focusing on IIoT solutions as R&D engineer. For the past 3 years, Sachit is with Smarshall India as senior software developer IIoT in R&D department. He is primarily working on Smarshall's I4.0 strategy and solution development in the field of safety. Welcome, Mr. Swapnil and Mr. Sachit.
Thank you, Subhajit. Yeah, and before we start to the presentation, I would really like to thank you both the panelists. I mean, they have pressed a lot about IoT 4.0, so it makes it difficult, what we talk about IoT 4.0 more than this. But being, a leader into safety, area of machine or application point of view, we have some small identity into Industry 4.0 as well. So as you said, Subhajit, can you also put to the next slide? So here we try to see what we cover in terms of the agenda today. So here we see Industry 4.0, whether it is really hype or value add, when it comes to the different technologies, what all different technologies are there who can transform the industry production. What is safety and smart safety 4.0 in nutshell. Also some use cases we would like to share in this session, and some future challenges, I mean, without which it won't be so interesting, right? So let's go to the next slide. Yeah, I mean, a few years back, it was only a buzzword. I'm into this manufacturing industry like for 18 years, like I said. So I was hearing a lot, and I was trying to attend many such sessions where they were already talking about this buzzword. But now it has really come to reality, and you see people around you talking about it, implementing it, and everybody is in rush for that. But the basic questions still remain the same. Whether any of your problems in the manufacturing industry will be resolved by Industry 4.0, or maybe I would increase some sort of productivity, because these are like, when it comes to manufacturing, you have to put some ROI whenever you have to do some investment or any type of capitalization. Me and Sachit, we would try to give the answers based on our own experience into Schmersal into upcoming slides. Yeah. So can you move to the next slide, Subhajit? So we feel like as of now, these are the 9 different technologies. These are really helping a lot and transferring this Industry 4.0. It's not a, let's say, component business anymore. It's all about solution. It's like an ecosystem. And I mean, if you take any of such technologies, you need more and more. It cannot be even finished in one day, because there are a lot of things to be discussed about any of the aspect if you take it. What Schmersal is focusing on, there are some certain areas or technologies we have identified and which are very useful for us. And we just try to see how out of these 9 technologies, which are these we are using in the upcoming slides. And using this, how we have evolved to convert this buzzword into the reality now. Okay. So here we have a specialist, Sachit, who is quite experienced, what you mentioned, Subhajit. So he is quite passionate about IoT 4.0 and all. So I just invited him, and he will take over the next discussion further. Yeah.
Thank you. Thank you, Swapnil, very much. So first of all, let me give you a brief about that. Simmercial is basically a product company. So they are mainly into manufacturing of the safety products. So with respect to the safety products, also we are implementing Industry 4.0 by adopting IO-Link safety, which one of our panelists also mentioned that we are also adopting IO-Link safety, and we are also using the OPC UA and MQTT communication in our gateways to send the data from our field devices to the cloud. So this is where we, on the product side, we are working on. Parallelly, we are also working on the consultancy, where we provide the consultancy services to our customers, in which we do different kind of analysis, safety risk assessment, and there we have adopted the the Industry 4.0 parameters. Like, first of all, we will talk about that what are the things in which Simmercial is working on. Like, first of all, we start with the risk assessment. So we have different kind of things in which we work on with respect to providing consultancy services to our customers with respect to safety monitoring. So first is the risk assessment. Then we have the planning and the engineering part, where we do the planning and engineering of after the risk assessment, that how that the safety should be analyzed and what should be the actions should be taken to implement the safety parameters, to fulfill the safety parameters. Then we have the installation and the commissioning of that. So once we do the planning and the engineering part, then we do the installation and the commissioning. And last one comes the operations, in which we have condition monitoring, maintenance, troubleshooting, and the predictive maintenance. So one by one, we will take all these four blocks, and we will define that how we are adopting IoT technologies, or you can say Industry 4.0 technologies, in each block. So first of all, let's talk about the risk assessment. So earlier in the risk assessment, we generally used to take the photographs of the machine, and we used to do the analysis on the manual basis. We store the photographs, we do different kind of visual inspections, and see that where the inspection has to be carried out to implement the fencing or any other safety parameters has to be taken around. So now we take the photographs in the similar manner, and we do the checklisting, and we upload that data on the cloud. So that data right now, earlier it was only available with the people who are doing the safety analysis, but now it should be a central repository where we are analyzing the data, and we have different kind of algorithms which are checking that what are the safety loopholes which has to be taken care. So this is where we are adopting cloud and the simulation technology to implement Industry 4.0. Then we go to the next section, which is the planning and the engineering part. So in the planning and the engineering part, like suppose we have a machine. So once we do the risk assessment, so we have to do the planning and engineering where we have to implement the safety fencing, or we have to give them the suggestion that what the safety things has to be taken around. So in this also we are adopting the Industry 4.0 where we are taking a 3D scan of the actual machine. So once the 3D scan of the machine is taken, so it creates, it is uploaded on the cloud, and it creates a 3D model of that actual machine. So this is a virtual model. So now after this virtual model, we can implement the commissioning part. We can do different engineering sections that where the safety fencing has to be done. What are the safety parameters has to be taken around. So after the planning and engineering section, that machine will look like this. So what we have done the fencing around of the machine. And what are the things has to be taken care. Next is the step where we create a digital twin of that actual machine. So since the digital twin is basically of the digital asset, or you can say we have a physical machine of which we are creating a virtual machine, and we are sending the data from the actual machine to the digital twin. So in that we are sending the data using our different IoT gateways. So we already have our devices which are equipped with IO-Link safety, which are connecting to the uh, our safety controllers, which are equipped with OPCU and MQTT communication. So through those gateways, we collect the data from our devices, we send it to our gateways, and from the gateways, we send it to the cloud platform. And this digital twin is actually linked with that actual with the data which we are receiving from the physical assets. So this creates basically a digital twin, or you can say a virtual environment where we can do the different kind of testing, we can do different kind of commissioning, and once all that testing and commissioning has been done, so we go for the go live session. So here comes my uh, third block, which is basically, you can say, in the planning and engineering section, we also have an AR app where we can actually go to the physical asset. We can show that our mobile screen, or you can say the iPad towards the machine, which can form a fencing part, so that it can be very easy to analyze that how once we implement in the actual scenario, how it will look like. This is how it works. Then we have the installation and the commissioning section, in which we have the digital twin where we do different kind of testings on the digital twin. So suppose we have run one test, and suppose one test one is failed, test two is passed, test three is still failed. So we will do the re-engineering section. So now the errors are decreased. So now the errors are one. So now again we do the re-engineering part. So now if suppose all the tests are passed, so we will go to the on-site and we will actually implement that fencing and everything, whatever the safety parameters we have analyzed during the risk assessment section. So then we will do the installation of the safety PLC program and the go live section. So this is how this installation and the commissioning part works once we do the uh, planning and everything. So this is how we are using the technology which is known as the simulation, or you can say Industry 4.0, how we are utilizing the Industry 4.0 ecosystem in this. Then we have the last section, which is the operation sections. In operation section, we have condition monitoring. So condition monitoring is basically getting the data from the actual asset. So we have the physical asset, so getting the data from the actual asset and showing it on the virtual cockpit, or you can say a digital twin, and doing different kind of analysis. So this is something which looks like this. So we have the we will get the data from the actual machine, we will send it to the our safety cockpit, and we will have the sign that whether the door is open, door is locked. So this is how you can do the condition monitoring of the actual machine. Then we have the maintenance part, which is very important. So suppose if some component is not working, it stops working. So how we have to do the analysis, we have to do the diagnosis that which component has failed, when it failed, and how we can resolve that. So similarly, this platform can help in that also. So we have the machine, so we can see that how many times the door was opened. We can see the actual statics of that machine. So here, suppose some peak is there. We can also segment different time frames. That suppose we have different shifts, so we can segment those different shifts, and we can figure out that in which shift how many times that door was operated. Then suppose if some errors comes up, so suppose some error comes up, so it will highlight on the safety cockpit that what is the error. So earlier, before implementing this kind of solution, the operator has to physically go to that particular machine, has to see that how many blinks are happening in that machine to figure out that what is the error. Now once we get the data from the actual asset, so we have the algorithm running backside on the back of our cloud safety cockpit, which will highlight that what is the error, and it will populate on the screen. So you can figure it out and you can resolve that error as soon as possible. Then comes the troubleshooting part. Like suppose if we have a remote support team and we want to suggest that how that uh, error or the problem has to be resolved. So for that we have a mobile app which is working on the augmented reality. So augmented reality based. So we have the central server where the operator will let us know that what is the error, and with the help of the augmented reality app which is on the operator side, he can actually move that screen towards that machine and can figure out that this is the problem and how it has to be resolved. So this is how this we are using the augmented reality and the simulation, again the simulation technology to implement Industry 4.0. Now we have the next case, which is basically the predictive maintenance, which is very important. So to decrease the shutdown of the machine or to decrease the how to increase the productivity, so we have to do a predictive maintenance. So for that, again, we are capturing the data from our components using our IoT gateway, and we are sending it on the cloud. On the backend, we have different kind of AI and ML algorithms running, which will predict that what is the time period when this device is going to fail out and when we have to replace. So in this also we are using the big data analytics and the cloud platform to find out the remaining lifetime of that machine. So this is how it looks like: 27 years, 12 weeks, 5 days, and 18 hours, which is decreasing. So yes, so these are some of the these are some of the things on which we are utilizing our Industry 4.0 ecosystem to make our processes better and to give a better safety solution to our customers. Then we have different kind of future challenges also, like we will have the mobile machine, we will have the self-learning robots, make which will make the use of the AI and ML to make machines more intelligent and safe. Thank you so much.
Thank you, Suchit.
So can you stop screen sharing? Yeah. Okay. Thank you so much, Mr. Swapnil and Mr. Sachit, for this wonderful presentation on safety in the era of Industry 4.0 and how it helps to enhance productivity. So delegates, if you have any question for Mr. Swapnil or Mr. Sachit, please submit it in the Q&A box in your Zoom control panel. So thank you so much, Mr. Arvind, Mr. Swapnil, Mr. Sachit, and Mr. Rishi for sharing your views through individual presentations. We will now have a panel discussion that is the most interesting segment of today's event. That is a brainstorming session on the top trends to watch in the Industry 4.0 space. So may I request all the panelists to keep their camera and audio on for the entire duration now. Ladies and gentlemen, over the past few years, many developments have shaped several Industry 4.0 technologies, primarily thanks to the innovations in software and hardware. So now we will discuss and deliberate on Industry 4.0 trends and opportunities it offers for manufacturing firms. So to start with, Mr. Arvind, according to you, what are the top trends to watch in the Industry 4.0 space in the time to come?
Well, IFM Electronic basically started its journey manufacturing field devices like sensors and now building up, giving system solutions. So in initial, any initial, OE is the key driver for IoT application.
Right.
Being sensor manufacturers, when the sensors getting connected to PLC for controlling a machine or process, now these sensors or the field devices want to become smart. So to introduce smartness inside any sensor or field device, what we think is that the IO-Link, which is giving not only the variable of the field device, but also the diagnostic data. So the data which is coming from the field and which is now able to connect or transmit not only to control the machine and the process at one side, but also on the other side to give a trending on the server side. So the first step or the fundamental step of introducing Industry 4.0 or implementing Industry 4.0 is smartness of or smart chip of IO-Link, which we feel that one of the very prominent trend what we see in, especially in manufacturing industry. Second thing, what we can also see that artificial intelligence, which some of our products actually into the database management could actually see the pattern or the historic pattern of the data as well as the current trade pattern, and they can ensure that the machine which actually performs as per the requirement. Third, what we can say is that augmented reality, where some of the applications which can be solved very easily. Of course, there are so many other trends like 5G and 4G, and then Web3 and then cloud also. But slowly, this Industry 4.0 is getting a lot of interest.
Okay. So, Mr. Swapnil, from the context of safety, what are the top trends you actually foresee for the Industry 4.0?
Yes, Subhajit. So, I just try to compare with my earlier experience when I was in automobile. In 2005 or 6, when people used to buy a car, they used to ask whether they can buy a car without airbags, because this is costing a lot of money.
Right.
But these days, if you see, this is now mandatory. No? This is quite, people are paying for it. I think Industry 4.0 will also bring the values for safety for sure, because right now this is a trend, and now people are when it comes to a data, especially a data or any human safety or any machine safety, for example, it's all about security and safety aspect, which are quite important. When you put it on cloud, you are rest or not sure that whether your data is safe or not. When it comes to component, either you placed it somewhere, but you are not sure whether it is functioning correctly or not. So that sort of security and that sort of safety, I think this is a trend which I see in upcoming time is quite important, and people are focusing a lot on this part now.
Okay, Sachit, would you like to add something to what Mr. Swapnil was saying?
Yeah, I would like to add that from the commercial point of view, as Mr. Arvind has said, that the IO-Link is very important. So we are also working on the IO-Link part. So we are adopting IO-Link safety because it's a two-wire communication and we can send a lot of data with that. So we are working on that. Plus the OPC UA communication. So interoperability is also a factor in that. So that we can have a vertical integration as well as horizontal integration within the different company products. Like suppose if I have a commercial product and I have a Siemens or an IFM product, so I should communicate among each other. So for that, we will be adopting the OPC UA. So I think most of the companies are adopting OPC UA, but it should be more adopted so that easy data transformation should be very flexible.
So like you mean to say that it should be open source? Okay.
So yes, something like that. In which like suppose we have initially right now we have proprietary communication protocols like
Right.
Profinet we have. So only the Siemens can communicate with that. So similarly, if we have the OPC UA, you will not have the restriction that your field device will only communicate with the Siemens. It can communicate with any field controller, or it can have a vertical integration as well as the horizontal communication. If you want to communicate among the devices, so that is also possible. If you want your device directly communicate to the cloud, so that will also be possible. So this kind of flexibility should only be provided by adopting MQTT and the OPC UA. So that is still in the initial stages, what I can say.
Okay. And as Rishi works on the area of IT/OT integration, what exactly you foresee, Rishi?
Yeah, so basically, as we have seen in the panel discussion also, Sachit has the challenges of this. So this is the challenge which is all customers are facing. We see a laptop, we can put Linux or any OS on the laptop, but we need a charger dedicated to that laptop. So we need a universal charger for charging our laptop. So like this, we need a solution which can integrate all the existing devices to the new technologies and to the that where IT OT convergence come into the place. And when we talk about, it's like a cake icing on it. So we need a bread to support that, where IT OT convergence is very much needed. And Redline has the solution of that with all the protocols, stability and connectivity solutions, which help customer to achieve and overcome these challenges. Because this is a basic level challenge which can be faced by anybody to where there are multiple vendors, and the development is during the eras. There are a lot of eras to develop from machines. There we have seen a lot of we are into industry 4.0 and talking into industry 4.0. So all the retrofittings and machines need to be integrated with all the new platforms, and in which Redline helps a lot with the new devices, with all the protocols and the good protocol library.
So if I'm not wrong, what Rishi, what Sachit was asking for, you already have a solution. If I'm not wrong.
Yes, because if we are not able to get the protocols, we can use Redline hardware and we can integrate it to OPC UA and other protocols.
Oh, that's great. So when we were talking to this panel, what I got to understand that from the points raised by Mr. Arvind, Mr. Swapnil, Rishi, as well as Sachit, what I could jot down is the top trends which are going to actually dominate the industry 4.0 spaces. One is IO-Link, then second one is artificial intelligence, then better augmented reality. Then Mr. Swapnil talked about safety and security. Then Sachit was talking about interoperability, and Rishi was like better and universal IT OT convergence. I think that is how we can sum it up. Anything else, Mr. Arvind, do you see that that is going to drive the segment, apart from what I mentioned right now?
So basically, as from IFM electronic point of view, we started our journey with the field device manufacturing, and we are slowly gearing up to give system solutions up to Monio platform, which is a software which actually gives you solutions with respect to condition-based maintenance, energy-based systems. So here, the data simultaneous integration through edge computing is also one of the new promising future what we see with respect to new requirements here.
Great. So edge computing. Swapnil, anything else?
No, I think you perfectly jot down everything, Subhajit. So the trends are quite clear, that it's all about augmented reality, artificial intelligence, and the data security. Yeah, quite well.
So now we'll try to understand that how these companies, now they represent IFM, Redline, as well as Mercell. So we'll try to understand how these companies are adopting Industry 4.0 and how they are enabling manufacturing companies to adopt Industry 4.0. So again, can I start with Mr. Arvind?
Yeah, to see, say somewhere around 2005, actually we realized the need for a low-priced digital communication in the market. I mean, surpassing any competitive boundaries. And this is how the IO-Link was born. I mean, the development of this communication standard marks the foundation of Industry 4.0 on the level of sensors, industrial communication, and actuators. And all this happened, I mean, without anyone even knowing about the term Industry 4.0, which is actually we see somewhere around 2015, 14 something. And then in 2010, it becomes clear that IFM needed a holistic digital strategy. It was also evident that this meant around 10 years of dramatic change in the company. So our entire product assortment, as well as all the internal process, needed to put on the test bench. And we also have accepted from the beginning that our strategy was going to be a dynamic one. Yeah, we continue to assess this on the regular basis to make sure that we keep in line with market developments. So conversion of all internal IT system into one central global infrastructure. That means before we can offer our customers a digital solution portfolio, we need to become a digital company ourselves first. And then modification of the product range, like say all sensors, masters, devices, all IO-Link, Ethernet to activate digital communication capability. So from sensors, the sensor data to networking, to pre-evaluation, to ERP, and to the cloud. Then 3D and software solution as the main priorities of our Industry 4.0 product strategy. Consistent implementation of digitalization within the company. So hardware, software, and services, all these are going into the same, everything from say single source. So from product component vendor to solution provider, everything is in creating a new business model based on digitalization.
Great. That's good. Savnelji, would you like to add how
Yeah, I mean,
Yeah.
these days, it is also difficult to prove that this is Industry 4.0 solution.
Exactly.
And when I go to the customer, for example, they are also not sure what they want, at the eventually.
Okay.
So what we are doing, we are also trying to find in-house requirement, and we are trying to educate our own sales team, for example, or the production people. And we are trying to set our own, let's say, proof of concept kind of stuff, which we can then, show to the customer and then see, okay, when you do this, you get a value addition like that, for example. And this is what we are heavily working on. And we are sure one fine day, customer will also trust based on this, and they would also get some value from our solutions.
Yeah, Sabri, that is what even I could understand. I could sense when I had a very explicit interview with your top management from Germany as well as from India last week. So that is great. So Rishi, anything else you would like to add, like how Redline is adapting to Industry 4.0 and how they are enabling manufacturing companies to adopt Industry 4.0 proactive approach?
Yeah. So basically, Redline, we had discussed, started in 1972 with sensors, and in 1976 with panel meter, they came into the display, the basic display of the processes on the local panels. So they have we have invented panel meters in 1976, and in 2004, it had designed the protocol converters with 300 protocol library from there, and now it is increasing to a cloud and others libraries. So it is a vast experience of protocol conversions, integration to the different OT platforms, and it's developed in the decades to publish all these things to the IT infrastructures, and it has a vast experience in IT OT convergence and also in the visualizations, networkings, and connectivity solutions. So all the products are designed and manufactured in US and Pennsylvania, and it has a great role in remote assets monitoring, remote conditional monitoring, assembly line monitoring, and all these applications.
Okay, Shachit, anything else? What apart from what Mr. Swapnil was talking about the role of commercials?
Yes. So I just want to add few points. Commercial is working basically on the three business models, like from the hardware part, from the software part, and from the internal projects. From the hardware solution part, we are implementing. Earlier, we were having SD communication in our field devices. Now we are implementing SD 4.0, which is having a more enriched data protocol to send more operation, like more data from our devices. Plus the IO-Link safety we are implementing in our devices. From this is talking about the field components. From the gateway point of view, we are implementing OPC UA and MQTT protocol in our gateway devices, through which we can directly give the connectivity of our field devices to the cloud and to different platforms. We are also working on different kind of data models, through which we can directly partner with the machine manufacturers. There are different kind of OPC UA data models like the UMATI and MT Connect. So we are trying to adopt those kind of data models in our safety devices, safety gateways, through which we can give a direct communication, direct integration of our devices into the machine builders. From the software point of view, I have shown right now that we are working on the augmented reality application. We are working on the condition monitoring application. We are getting the data from our devices. We are also focusing on combining safety and the non-safety data. So right now you have seen the safety solution, but we are also trying to integrate the non-safety data also, and trying to correlate that how combination of both safety and non-safety can give a value addition to the customers. And with that, we are also adopting IoT projects internally in our company, like the energy management system and all, which is very critical right now. So that is also we are working on. So adopting Industry 4.0 so that we can give a confidence to our customers that we are also adopting it and it should help you also. So that is how we are working on.
Okay, great. So thank you, panelists, for being so participative in this discussion, panel discussion especially. It is clearly understood that Industry 4.0 adoption is unavoidable to achieve greater competitiveness and productivity. We cannot just deny it. So we are now going to start answering those questions. There are quite a few questions submitted during the today's presentations. As a reminder, viewers, if you still have any questions, please submit it in the Q&A box in your Zoom control panel. So I'll take one by one. The question is from Mr. Syed Afroz Ahmed. He's asking that, I think that question was directed to Mr. Arvind during your presentations. Do you have any augmented reality app to scan QR product code to get detailed information of product if things need to be replaced, maintenance details info?
As of now, the app development is only on a Monio platform, which actually gives you data on your app, the connected field devices, especially sensors of IO-Link and to the IO-Link masters. Augmented reality is coming in the next phase. So as of now, the app development is going on that. But the augmented reality is actually on the desktop or say mobile, that server side, it is already been made.
Okay. Anyone else would like to add anything like Rishi? For your product range?
Yeah.
Is it relevant to your product range?
No.
Okay, fine. So the second question was from Mr. Sai Krishnan G. Iyer. He is asking that how reliable artificial intelligence is in auto sector. So if I can just put this question in a different way, as Rishi was talking about, handling of huge data during the process, whether it's big data or whether it's you talk about digital twin. So how do you ensure the security of that data? How safe is that?
It is to me.
Yeah, Rishi.
Yeah. So basically, the data safety is there with different cybersecurity norms, and it is updating day by day. And we have encryption and decryption, then TLS and SLS connectivity, which ensure that our data is safe, and we push it to the servers. And in the today infrastructure where we see the cloud servers are playing a vital role, so data security is a challenge, but it is well addressed till days, and it is well encrypted and well advanced with the customers.
Okay, Rishi and Sachit, when you actually advocate for a kind of open source or a kind of universal protocol for this, so how dangerous that is going to be, or is it at all going to be safe? And if it's going to be safe, what are the actions can be taken?
Yeah, so when we talk about the open protocols and others, so it is in the OT level. Right. When we switch to the IT levels, the norms of IT and cybersecurity are well handled by the products or by the devices. So in OT levels, we have to collect in the local level data, and we have to push it to the IT infrastructure. So in OT levels, the data protection is there. Inside the industry, we always see it's protected, and it's managed by the managed switches and managed networking portfolios. So that data is get protected. And IT levels, we have the norms and securities. So there is an isolation by the device, which isolate the IT and OT data, and which provides the data with security.
Sachit, when you Simarsal,
I have to drop out from this call because I have to jump into another meeting. I'm sorry.
No
Sachit is there.
Okay,
and I think I must say thank you all for listening us patiently.
Yeah. Thank you so much. It was great having you.
We'll be in touch for sure. Sorry for that. Thank you.
No worries. So Sachit, when you talk about Simarsal, you deal with the safety. So safety, again, the safety of data is also a growing concern. So are you also equally concerned about what Rishi was talking about, or even the question what we received?
Yes,
and
so Rishi was talking.
How Simarsal is working on that.
Yeah, from the gateway point of view, if you talk about, so there every time this OT network and IT network are differentiated. So we work on the production network when we directly deal with the OT component. So it has different kind of securities. which are managed by the IT department by encryption and all. From the gateway point of view, there are different kind of encryptions and SSL certificates are there in the gateway, basically differentiates between this OT and IT network from the security point of view. And from the IT side, we already have the firewall and all where the data is being sent out.
Okay. So, Mr. Arvind, how cyber security, how cyber safe are your products? If you would like to talk about that.
In fact, from when we begin, it's a hardware. So
Right.
when we introduced Ivory Masters itself,
Exactly.
we had two ports, separate physical ports on the Ivory Master. One port is assigned to a control network, and another port is assigned to an IT network. Two
Yes.
ports have separate IP addresses. That means IT is not able to see what a machine is there, because the end user's requirement is that the main purpose of a machine is to produce or to production. Whatever the data wants, it has to be parallelly going to the IT network for their analysis and everything. So in the master itself or in the hardware itself, we have two separate IP address and separate ports. And of course, in the IT network, we have dedicated security arrangement is already there. But we have already done this on the hardware itself.
Okay. So there is a very relevant questions for your product range, Mr. Arvind. IFM RV6016, RV6045, and RO1377 encoder spare parts got obsolete, according to Mr. Satish Kumar. So what are the models for its replacement, if you can just address that?
That particular encoder is already been upgraded to ROP510, and it is available in the market since last more than 5 years.
So, Mr. Satish, we would request you to just drop a mail to us. We will take it up with IFM management, and we'll give you details. Yeah, sure. And question very directly to Mr. Sachit: do you have your own gateways with OPC-UA and MQTT protocol?
Yes, so we are working on these kind of gateways. Initially, for the testing of our solutions, we are using a third-party gateways, but we are also working on our own gateways, which we will be releasing soon.
Oh, so that question was from Mr. Jaiprakash Patil. Okay, and Mr. Syed Afroj is saying that it was nice discussion, got valuable information. Mr. Prasad is saying that for continuous process industry or production unit, how the data collection and safety norms maintained through existing data simulation. Rishi?
Yes. So basically the data simulations can be achieved by acquiring the data and processing it. And through AI/ML codes, there are libraries developed by the IT industries where we have data process and we simulate the data and we give the data to the visualizations where it can be a data story which can be easily understandable.
Okay. Mr. Arvind, would you like to add something?
I think it's not relevant to our kind of manufacturing.
Okay, fine. So there's a very interesting question from Dr. Kalicharan Rath. I don't know who can take up this question. How much percentage of Indian companies or manufacturing industries are adopted Industry 4.0 till now? So is there any data as such?
See, if I say when there is an importance given to a data, there's always a tussle between smart data versus big data. Process relevant data needs to be aggregated and analyzed near the source to avoid unnecessary clogging of the data network. So, Industry 4.0 requires here attention of top management and maybe owners of that each company. This means one has to be active in the respective committees which are responsible for digitalization of the business process, understand the details and actively live into the new structures. So, we have to be aware. We have tried all this before and it doesn't work. No, a lot of what was not impossible in the past is now simple. So there is always a yes, and people are slowly actually getting into Industry 4.0 implementation. Yes, the hard part is to how to analyze the data. Yes, it is related to its own users.
Okay. Dr. Rath may not be satisfied with the kind of numbers what he was expecting, but one thing, Dr. Rath, what we can say is, if you see the data of manufacturing IT spend, it was 5% in 2011, and now in 2021 it has been rose to around 20%. So that is how actually the industry 4.0 is space that is gaining a kind of momentum, if I'm not wrong. Then there's a question, it was very interesting question, I kept it deliberately, that was from Mr. Imran Basha. What are the challenges in India for implementing industry 4.0? That is universal question. So can I start with Mr. Arvind Telange, if you can just talk about a few challenges.
See, in every implementation of a new technology, especially Industry 4.0, again, OEE is the key driver for IoT applications. See, for the automation, for the sake of automation is no more of use. Every investment, either it is CapEx or OpEx, has to have an ROI output. So, first of all, we have to find out what is the output we are going to come out with the Industry 4.0. Of course, there are advantages of implementation in Industry 4.0, but at the end of the day, if you are getting output and efficiency output increase, yes, it's of course. If I see the trend and the experience, what we have actually given some lines with IOLINK, people have used because it greatly reduces, first of all, the wiring. It actually gives, if you see in the entire line, they hardly see any control panels. So next time when they actually comes out with another expansion or a slight modification, people always find out very easy and accustomed with that IOLINK implementation, and they also ask for the future expansion with IOLINK.
Great. Rishi, what are the challenges you see?
Yeah, so basically, if we look into the challenges, it is ROI, meant to show the customer the return over investment. So there is always a ROI in adopting a new technology, but it depends on the customers, how fast they are eager to know and how fast they are eager to change. So this takes some time for explaining the customers, because we need data and their machines and all the things to be incorporated with the technology, and then they can feel the differences. So it takes some time, which is a challenge in India to show to customers.
Very valid. And Sachit, from Simersal's point of view, what are the challenges you see?
First of all, we see the challenges in getting the resources which are having the adequate technical skills to implement the Industry 4.0. So second one is the data, like data interoperability, which I have already shared with you regarding the OPC UA. So basically, OPC UA will be able to solve the intercommunication between the components and the devices. One is regarding the security point of view, that many of the customers, when we talk about implementing Industry 4.0 solution, they are very much concerned about the IT security, that how how we can assure the data security to them. So these are some of the challenges which we face.
That's good. And the very specific question again directed to Rishi: do your gateways support OT level PLC protocols and OPC UA and MQTT protocols in single gateway?
Yes. So our gateway, we have a gateway which supports all the protocols. So we have MQTT, OPC UA, and all the industry level protocols.
Right. So I was having a question. So I actually kept myself this thing. That question raised during the presentation of Mr. Arvind, and he could not address that, I know, due to paucity of time maybe. So you were talking about the role of predictive analysis, in this particular space. So if you can tell us more about the role and why Industry 4.0 solutions are becoming more significant in that particular context, and how important is predictive analysis?
See, the concept of condition-based maintenance, if we analyze in thoroughly, for example, about monitoring of a power pack, or monitoring of a pump, or monitoring of a motor, we have a traditional ways of analyzing it, finding out, or going from breakdown maintenance to predictive maintenance. We have to find out what are the parameters and how they are actually behaving, and we have to find out the trend of these parameters with respect to, for example, temperature, for example, pressure, for example, flow, or for example, level, or for example, oil quality. All these parameters, when we actually get this data from the sensors, and when we not only go give this data to control the machine, but also and make a trend of all these data, we can predict and we can say that yes, maybe after 2-3 days, this machine is going to down because of the oil quality. So this way, you can actually better make a prediction of a future downtime well before, and we can actually make an action to correct this.
Right. So as we do not have much of questions, I would like the panelists to submit off with 30 seconds of kind of concluding remarks on what is the future of Industry 4.0 domain in the context of Indian manufacturing sector. To start with, Sachit.
So from the Industry 4.0 point of view, so I think there's a very good scope. Many of the companies are working on different kind of sectors. Like if I talk about safety monitoring, energy monitoring, OE monitoring, machine monitoring, and many of the customers are also getting realization that what are the benefits they will get from these kind of solutions. So I think that there's a very good scope in the future.
Rishi.
Yeah, so my views is always India has proved that it has smartly moved to the new technologies, and it is moving now. Also, we are also feeling the same, that it is moving to the Industry 4.0 trend, and it is using its benefits. It will take at some time, but it is giving. We have seen the energy monitoring solution, assembly line monitoring solutions, and all these solutions are adapting by the companies and the customers. So it will go a long way, and it is moving.
Arvind, sir.
In today's context, I mean, we have to actively participate in the design of the new digital products and understand the background. For example, we have to ask ourselves what young people would do. I mean, if a digital native today decides to open a transportation or logistic company, they would never think about opening a career company. They would rather think about opening a digital platform to provide the respective services. This is how the new startups and ventures are actually coming in a big way and making successful businesses.
So you mean to say more of a kind of service provider?
I mean to say digital platform providers. When I mention about an example of a transportation company,
yeah,
they will not think of more first about the carrier company,
exactly,
but they will first of all think about an app or digital platform first.
The aggregator kind of. Okay. Yeah. Okay. And so will there be a kind of impact when you get 5G in full force?
Yeah.
Will there be an impact when we get 5G in full spectrum?
Of course, 5G is going to be the future of the business, because it is actually helping us to get the data, and it will really help and solve many critical applications in a few minutes of time or a few seconds of time.
Right. So once again, thank you so much, Mr. Arvind and Mr. Sapnil, who is not there now, Mr. Sachit and Mr. Rishi, for taking those questions. It was my pleasure having you here today. Thank you, delegates, for attending. We hope you have enjoyed this 33rd episode of Mojo for Industry Development Debate on top Industry 4.0 trends and innovations in 2022, sponsored by IFM Electronic India Private Limited. One more announcement, we will soon premiere an edited video of this entire session on our YouTube channel, Mojo for Industry Media. Please subscribe to the channel and you will soon get the notification. So with that, we conclude this session. Thank you for participating in today's development debate. Wish you all a happy Diwali in advance. We hope to see you again next time. Till then, take care and stay safe.
Thank you very much.
Thank you very much. Thank you.
Thank you, sir.
Thank you.
See you soon, sir. Bye.